Hello friends, welcome back to your channel Yugandhara, where we talk about civil and structural engineering. This is the part 2 of the contract document and detailing process. In part 1 of this contract document and detailing process, we have seen the design build process and the types of contracts and the operating datasheet. The link for that video is provided in the description box below. Now let's start today's video. Contract document and detailing process part 2. Chapter 2, page number 2.6 and 2.7 from the manual detailing for steel construction by AISC and NIST. Today's topics: plans and specifications, design information, plans and specifications. Specifications describe how work is to be accomplished, and plans, that is design drawings, show how the structure will look. They show the shape of the structure, sections and sizes of members, location and arrangement of members in the frame, beam or girder camber, floor levels, and roof and column, sees enters and offsets, with adequate dimensions to convey accurately the quantity and character of the structural steel to be furnished. Also, details of structural joints, bearing stiffness on beams and girders, beam web reinforcement, opening for other trades, connections between the curtain wall and the supporting frame, column stiffness, column web doubler plates, column anchorage and column splices are given. Notes listing the types of fasteners, applicable design specifications, for example AISC, RCSC or AWS, grade of steel and type of paint to be used are included with other instructions specific to the construction of the structure. Sufficient information concerning loads and forces to be registered by the individual members and their connections should be given in the design drawings. Such forces include shear and axial forces in beams and girders, shear forces and moments at column splices and bases, moments at beam ends, and axial forces in diagonal bracing. See AISC Manual Part 2 and AISC Code of Standard Practice Section 3.1 for further information. Now we will see design information. In that, this is given from the Appendix A, Figure A766. This is light industrial building truss. We will see about it. Now we will see the terminology for truss so that we will understand the drawing quickly. Here in this drawing, two trusses are there. These are the walls and this is the roofing material. So here the span is given. Span is the center to center distance between the supports. Ridge or apex is the topmost point of the truss. And angle of pitch, it is the ratio of rise to span. Base, distance between adjacent trusses. So this is the truss. In the truss, these topmost elements are called top chord member. Most elements are called bottom chord member, and these intermediate members are called wave members. Now in this picture we can see that here the supports are there, and these supports, the truss is there. On the truss purlins and on the purlins roof covering material is there. So what is rise? Rise is distance between the bottom chord and peak point. What is slope? Slope is the ratio of rise to the half of the span. Purlins are here. These span from truss to truss and subjected to transverse loads and the rest on top chord of the roof truss and carry the load of roof covering material and transfers it to panel joints. These are the panel joints. So what is heel joint? Joint at support are known as heel joint. Peak joint, this is the peak joint. Joint at apex. And eaves. Bottom edge of an inclined roof is called eaves. Now we will see rafters. These are the rafters. These are placed transverse to the purlins. And principal rafter is upper chord or top chord member of the truss. Truss components are, this is the truss and it is supported on the columns here and here. These are the purlins. These are the girts, horizontal members supporting the wall panels. These are the sag rods aligning the girt members. These are the cross members are the bracings. The composite plan view shows both top and bottom chord bracing. These are the top chord bracing and these dotted are the bottom chord bracing and the brace base requiring sway frames. The size of eave struts is indicated on the plan, but their location is shown on the typical wall section. So here it is written as end of purlins and eave struts. So these are the eave purlins and on their side these are the eave struts. In typical wall section, these channel sections are eave purlins and these angle sections are eave struts and gutter is provided to collect the rainwater. Of purlins and girts are shown in the top chord plan and in the side elevation. In the side elevation, the size of girts, that is C6 by 8.2 is given and the size of the purlins is given in. Sag rods are used to align the purlins and girts. So in side elevation, girts are used to support the wall and these are the sag rods. These are used to align the girt. And for purlins, here the cross section is taken through the 60 feet width of the structure and shows the sizes of columns, knee braces, and truss components. These are the knee braces and sizes are also given for it. For knee braces it is 2 angle section 3 by 2.5 by 1 by 4. And the designer has indicated the required forces and loads in the truss and knee braces by the steel detailer to develop adequate connections. Two sets of forces are indicated, those produced by gravity, that is vertical loads, and those caused by wind. The wind forces are given by plus minus designation to indicate tension or compression because the wind may blow in either direction against the sides of the building. The gravity forces, because they are produced by loads which act in only one direction, are either positive or negative, never both. So in this cross section, top chord, here it is minus 82, minus 80, minus 70. So these members are in compression and the section is two angle sections 4 by 4 by 3 by 16. And here the forces are plus 66, plus 78, plus 45. So it is in tension and the sizes of the members are like this. So here one note is given. Members 1L 2.5 by 2.5 by 1 by 4 except as noted. Wind stresses shown thus plus minus. So here for this member plus minus 27 is given. This is also minus 15, so it is in compression. Column, it is W12 by 26. Yes, 2-8 and 2-9 of the manual define the several kinds of loads and their combinations to be applied in designing truss joint. One of the advantages of listing the forces as in figure is that the design drawing indicates whether any of the double angle truss members may be subject to both tension and compression. If the magnitude of the reversible force is such that a dead load tensile force is less than the compressive wind force, the spacing of the stitch fasteners or welds connecting to two angles would be governed by the more restrictive requirements for tension or compression members. Design drawings of trusses should show all dimensions that are required to establish necessary working points and distances between working points. The columns in figure have been proportioned by the designer to resist bending from the moderate amount of wind load against the wall siding. The column bases are assumed free to rotate unless otherwise specified by the designer. Therefore, the required column details are relatively simple. Summary: we have seen the plans and specifications, design information given on steel industrial building, and terminology of the truss components. For the content in the video, all credits are given to the AISC committee who prepared the manual detailing for steel construction. I am grateful to them. Thank you so much. Thank you so much to you all for being with me throughout this video. I am grateful for your support. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.